Q8336. Which of the following fire detection systems will detect a fire when an element is inoperative but will not test when the test circuit is energized? A. The Kidde system and the system. B. The Kidde system and the Fenwal system. C. The Thermocouple system and the Lindberg system. The correct answer is B. The Kidde system and the Fenwal system are two types of fire detection systems that will detect a fire even when an element is inoperative, but they will not test when the test circuit is energized. In these systems, the fire detection elements are designed to respond to changes in temperature, smoke, or other fire-related factors. If an element within the system is inoperative or faulty, it may still be able to detect a fire by relying on the functioning elements within the system. However, when the test circuit is energized for system testing, the inoperative element may prevent the system from completing a successful test. This means that even if the system can detect a fire under normal operating conditions, it may not be able to undergo a proper functional test. Q8337. Which of the following fire detection systems uses heat in the normal testing of the system? A. The Thermocouple system and the Lindberg system. B. The Kidde system and the Fenwal system. C. The Thermocouple system and the Fenwal system. The correct answer is A. The Thermocouple system and the Lindberg system are two types of fire detection systems that use heat in the normal testing of the system. In these systems, heat is used as the primary factor for fire detection. The Thermocouple system utilizes thermocouples, which are temperature-sensing devices, to detect changes in temperature indicative of a fire. The Lindberg system also relies on temperature-sensitive elements or sensors to detect fire conditions. During the normal testing of these systems, heat is applied or simulated to ensure that the fire detection elements respond appropriately. This testing process helps verify the functionality and effectiveness of the system in detecting fires. Q8338. After a fire is extinguished or overheat condition removed in aircraft equipped with a Systron Donner fire detector, the detection system? A. Must be manually reset. B. Automatically resets. C. Sensing component must be replaced. The correct answer is B. After a fire is extinguished or the overheat condition is removed in an aircraft equipped with a Systron Donner fire detector, the detection system typically automatically resets. This means that once the fire or overheat condition is resolved, the system resets itself and is ready to detect any future fire or overheat events. Q8339. The use of water on Class D fires? A. Is most effective if sprayed in a fine mist. B. Will cause the fire to burn more violently and can cause explosions. C. Has no effect. The correct answer is B. Water is generally not effective for extinguishing Class D fires, which involve combustible metals such as magnesium, titanium, potassium, sodium, etc. When water is applied to a Class D fire, it can react with the burning metal, releasing hydrogen gas and potentially causing explosions. Water can also disperse the combustible metal, leading to a larger surface area for combustion and making the fire burn more vigorously. Q8340. For fire detection and extinguishing purposes, aircraft powerplant areas are divided into fire zones based on A. Hot and cold sections of the engine. B. The volume and smoothness of the airflow through engine compartments. C. Engine type and size. The correct answer is B. In aircraft powerplant areas, fire zones are typically determined based on the volume and smoothness of these airflow through engine compartments. This approach is commonly used for fire detection and extinguishing purposes because it allows for effective control and suppression of potential fires. By dividing the power plant areas into fire zones based on the airflow characteristics, it becomes easier to detect and respond to fires promptly, minimizing the risk to the aircraft and its occupants.